Okay, you should have downloaded this PDF, the Polynomial Properties and Sketching. I will tell you right now, there definitely is going to be a question like this on the test as an open answer question. So let's look. Notice that I have given you both the function in standard form and in factored form. Both forms are useful for different things. And here I'm not interested in whether you are able to factor this polynomial. I want to see what you can do with it when it is factored for you. So I want to find all roots of the function and state the behavior at each root. The factored form is going to be more useful for finding the roots. I set each factor equal to 0. I get a root at 11. Notice that the root of x equals 11 has a multiplicity of 2, which is an even number. I didn't ask you to tell me the multiplicity, but I did ask you to state the behavior at each root. You don't have to tell me that the multiplicity is 2, but you need to know that because the multiplicity is 2, the function touches but does not cross. That's what we mean by root behavior. Either it touches, it crosses, maybe it crosses with a wiggle. Alright, our next root is 1. That has a multiplicity of 3. So this crosses with a wiggle. And finally, my last root is negative 12. That has a multiplicity of 1. Remember, if nothing is written explicitly as an exponent, you can treat that as a 1. So it has a multiplicity of 1, which means it crosses with no wiggle. So now I want to talk about the end behavior. The standard form of the function is going to be more useful for looking at end behavior. Now the right end, remember on the right end, x always approaches infinity. On the left end, x always approaches negative infinity. It's really to see what the y's are doing on each end that you need to look at the actual function. So all I need to look at is the dominating term. My lead coefficient is negative, which means on the right end, this is approaching negative infinity. Now, to see what the left end does, I look at the degree of this function. The degree is 6, which is an even number. And because it is even, that means both ends go the same way. So since on the right end y approaches negative infinity and this function is even, then on the left end it also approaches negative infinity. So that is pulling all my information together. Now finally, I want to sketch a graph of this function. Now this is going to be a rough graph. It is not intended to be anything precise. I am testing your ability to pull all of this information together and synthesize it and get a good idea of what this function looks like. I know that it has roots at negative 12, at 1, and at 11. I know that on the left end, as x approaches negative infinity, y approaches negative infinity. So I know that it's going down in this direction, which means when I start sketching my function, it's increasing here. Notice that it crosses at -12 with no wiggle. That's something I said under the roots here. Now, I don't know how high it's going to go or anything like that. I don't know. I do know that there is going to be a turning point because it has to come back and cross again at 1. But I don't know where exactly that turning point is. You actually need calculus to know exactly where the turning point is. But like I said, this is a rough sketch. So I'm going to cross at 1. But notice that I said up at the top here, pull this down a second, since the root of 1 has a multiplicity of 3, this crosses with a wiggle. So I'm going to sketch in it crossing with a wiggle. And then finally, I've got another root of 11. And if I look up here, 11 has a multiplicity of 2, so it touches but does not cross. So we'll come back down. I'll pick up my sketch. And it touches the x-axis at 11, but it does not cross there. So I've got an arrow onto this end. I want to make sure I put an arrow on that end. And notice that my end behavior on my right end is what it's supposed to be. As x approaches infinity, y approaches -infinity. That means it's going down on the right. And so this is what I am looking for when I ask you to sketch a graph of a polynomial function. It has the correct end behavior and it has the correct root behavior. That is mostly what I'm looking for. One other thing that we could say about this function that I'll call optional. The y-intercept of this function, if I look back up at the function in standard form, when x is 0, all of these terms are going to be 0. And my y-intercept will be 4,356. So 4,356. Oh, so I labeled that on the graph. So notice my graph is certainly not to scale. At least the x and y axes are certainly not on the same scale, but that's okay. This is a rough sketch and this is exactly what I am looking for and exactly what you will be required to do on test 3 and probably also the final exam.